know that every time you hear that jingle, I am literally playing it with my little violin right here. Lies. It's all lies. Hey, you want to talk about something cool today? I do too. We're going to talk about dividing mixed numbers. Okay. What's a mouse's favorite game? Hide and squeak. Because mice squeak, hide and squeak. All right, like I said, we're going to divide mixed numbers. If you have watched my dividing fractions and improper fractions, this is going to be a super easy video. And you'll see why in a second, but we're going to work on dividing mixed numbers, and the denominators are going to be 12 or less. All right, math lingo. When we speak about fractions, when we're dividing them, we're really asking ourselves, how many parts can I break a fraction into? Good, good. All right, which means how many parts, how many fourths? Okay, so when I look at this, I always like to read when I'm dividing fractions, I love to read fractions backwards. It just seems to make things make a little bit more sense. So how many fourths can I break 1/2 into? You can also say 1/2 divided by 1/4. That's totally fine. But the concept I'm trying to get across to you is how many fourths can I break that 1/2 into? Okay, so division is the opposite of multiplication. In multiplication, we multiply straight across. Okay, so we just take the numerators and multiply them, and we take the denominators and multiply them. If you don't know that, watch my multiplication videos. So let's do the opposite of multiplying straight across. Let's go ahead and do a little thing called keep, switch, flip. This is all review if you've watched my fraction video, but just if you haven't, here you go. All right, so let's take a look and see what that means. When we say keep, switch, flip, what we're saying is we keep the first fraction. Just keep it, leave it alone. All right, so the first fraction is 1/2. Keep it there. Don't touch it. Hands off. And then we're going to switch the division sign into multiplication. Switcheroo! And that becomes bouncing, bounce. Isn't that cute how he bounces? And then the flip means we flip the second fraction over. So right now it's 1/4, and we are going to flip it. Bunny bun. All right, and now we've got ourselves a beautiful multiplication problem that we could simply just multiply straight across, okay? Now what we do is we say, what's 1 times 4? That is 4. And what's 2 times 1? That is 2. Can we simplify that? Well, we can. One way we can say is just what's 4 divided by 2? Or we can say, is there a number that goes into 4 and 2? So I'm going to do it that way this time, just for the fun of it, to see if you guys love it like I do. What number goes into 4 and 2? Well, 2 does. So we're going to divide the top and the bottom by 2. And what is 4 divided by 2? It is 2. What is 2 divided by 2? That is 1. What is 2 over 1? That's just the same thing as 2 wholes. All right, let's go. Now, bonus feature, talked about this in the other videos as well. If you don't know about simplifying by working diagonally, this is the thing you want to get into, all right? Because it makes your life so much easier. So in other words, if I were to simply multiply across, just like our normal multiplication tells us to do, if I were to multiply across, I would say, what's 4 times 3? Well, it's 12. And what's 9 times 12? It's 108. And then I would have to go through this long process of simplifying. Well, I don't want to do that, to be quite honest with you. So let's try a different route. Let's say we simplify diagonally. In other words, you're looking at the 4 and the 12. They are diagonal from each other and treating them like a fraction. Is there a number that will go into both 4 and 12? And you want to find the biggest factor that will go into 4 and 12. So 2 will go into both of them, but so will 4. So if I divide this top one by 4, so if I say divided by 4, what's 4 divided by 4? It's 1, so I can turn that into a 1. And what's 12 divided by 4? Well, that's 3, so I can turn that into a 3. And then I can do the same thing with the other one, all right? Possibly, if there is something that will work here. What's a number that will go into 3 and 9? Well, 3 will go into both of them. So I could say what's 3 divided by 3? That's 1. And what's 9 divided by 3? That's 3. And when you do that, your life becomes a lot simpler because now you just have to multiply straight across and say, what's 1 times 1? 1. What's 3 times 3? 9. And anytime we have a 1 involved, we are in simplest terms. Use this feature. So when you're doing division, once you get to the point where you have flipped everything over and turned it into multiplication, simplify. This is also a beautiful piece of artwork. It's just lovely. All right, dividing mixed numbers. Let's not make this too complicated, y'all. You already know how to divide fractions, and you already know how to divide improper fractions. So let's just change our mixed numbers into improper fractions and do what we already know. So now we have 2.5 divided by 1 3/4. Okay, so let's try this one. All right, so remember, we're going to try to keep it not very complicated. So we're going to convert to improper. We're going to keep, switch, flip, and then we're going to multiply and simplify. So first of all, let's convert 2 1/2 into an improper fraction. Okay, and then we're going to take 1 3/4 and turn it into an improper fraction. So what is 2 1/4? Or I'm sorry, what is 2 1/2 flipped into an improper fraction? Well, what is 2 times 2? All right, that's 4. We add the numerator to it, and that's 5. So we have 5, and we keep our numerator at 2. What is 1 3/4? We take our whole and we multiply it times 4, and then we add the 3 to it, which is 7. So we have 7/4. Okay, 5/2 and 7/4. So those are our new numbers. So let's turn that into a new problem. 5/2 divided by 7/4. So what do we do now? We keep, switch, and flip. Okay, so we keep the 5/2, we switch this into multiplication, and we flip that other one over. And then all we're going to do is simply multiply, or simplify and multiply. So we can do this cross multiplication game here, right? We could absolutely do this cross multiplication game, and that will tell us that, well, not cross multiplication, but cross simplify. You can't simplify 5 and 7 because the only number that goes into 5 and 7 is 5. And 5 won't go into 7, so that doesn't work. But we can simplify 2 and 4. And what we can say to ourselves is, what number will go into 2 and 4? And that would be 2. So then you just divide them both by 2. 2 divided by 2 equals 1, and 4 divided by 2 equals 2. Okay, you multiply across. What's 5 times 2? That's 10. What's 1 times 7? That's 7. And then turn it into a mixed number. And when you do that, how many 7s will go into 10? 1. What's left over? If I take 7 out of 10, I got 3 left over, and I keep the denominator. So what's our answer? It's 1 3/7. Pretty cool, right? It's the same thing, right? It's the same thing. So let's just try this one. 3 3/8 divided by 1 2/5. Well, what's the first thing we're going to do? We are going to convert to improper, keep, switch, flip. So here we go. 3 3/8. Let's keep, switch, or let's convert. How many times does 3 go into 8? Or what is 3 times 8? That's 24. And then we add our numerator, and that gives us 27. All right, 27. And we keep our denominator. Okay, divided by. Then 1 2/5. What's 1 times 5? That's 5. Add the numerator. That's 7. Divided by 5. Now what we need to do is what? Keep, switch, and flip. Okay, keep, switch, and flip. So we're going to keep that 27/8 as it is. All right, nice, nice, nice. And then we're going to switch the division sign into multiplication. So our new one is 27/8 times, and then we're going to flip this guy over, 5/7. And then we ask ourselves, is there anything that will go, any simplifying that will take place here? And I'm not really sure that there is, because 7 only has 1 and 7 that goes into it. If we count by 7s, we go 7, 14, 21, 28. It does not hit that. So that will not work. And then 5 only has 1 and 5 that goes into it, and 5 will not go into 8. So now we just need to go ahead and multiply straight across. Okay, 5 groups of 27. So 27 times 5. 7 times 5 is 35. Ooh, I'm going to change colors because I'm running into my other area. 7 times 5 is 35, okay? And then 5 times 2 is 10 plus 3, which is 13, okay? So our number on top is 135, okay? And then we multiply the bottom. What's 8 times 7? That is 56, okay? So that is our number, but we want to go ahead and turn that into a mixed number. So I'm going to need to erase some things to create some space. All right, so let's go and say, all right, and create some space. How many 56s will go into 135? How many 56s will go into 135? Well, if we count by 50, we could say 50, 100, 150. So 3 is probably going to be too big. So let's go ahead and multiply 56 times 2 and see what we get. All right, 2 times 6 is 12. 2 times 5 is 10 plus 1 is 11, okay? So we got 2 wholes, is our big number. And 112, we just took 112 away from that 135. So we got to go ahead and figure out what that answer is so we can get our numerator. What is 135 minus 112? Okay, 5 minus 2 is 3, 3 minus 1 is 2, and 1 minus 1 is 0. So our numerator is 23, and our denominator stays the same at 56. And that is our final answer. That's quite a bit of work because when you get with mixed numbers, you're going to get some interesting improper fractions. So you're going to have to do your times, multiplying 2-digit times 1-digit. You're going to have to do some pretty big division problems unless you get lucky. Where would you get lucky? And that's if you can get in here and do some simplifying early on, okay? All right, and remember with that simplifying, you have to wait until you get into a multiplication problem before you do the simplifying. All right, I think you're ready to rock and roll. As long as you know how to multiply fractions and improper fractions, you know how to multiply mixed numbers as well. So, why do birds fly south for the winter, I wonder? Well, it's because it's too far to walk and their feet won't reach the pedals of a bicycle. Hello. If they all got on bikes and started riding south, that'd be funny.